Thank you. Yeah, shout out to the organization. Thank you for having me. Today we are going to discuss the Oracle problem, the importance of decentralized Oracle networks. We're going to tackle a bit on hybrid smart contracts, and generally I would try to briefly explain you the Chainlink protocol if you are not already familiar with it. So my name is Andrej Rakic. I'm one of the developer advocates for Chainlink protocol at Chainlink Labs. You can see here listed my Twitter handles, my email, but you know, I'll be here with you in person, so feel free to reach me out to talk about anything Chainlink related. Actually, if any of you attended to Austin Griffith's talk earlier this day about gaming on Ethereum, we are hosting tomorrow live games for smart contract developers at 5:30. Tickets are sold out, but if you really want to attend and to play the same game Austin did earlier, hit me with a DM on Twitter and I'll try to add you to the list. But let's start with the agenda. So in the next briefly 30 minutes, we are going to talk about the Oracle problem, mainly about decentralized Oracle networks, and as I said, about the Chainlink protocol itself. So to understand the Oracle problem, we first need to understand the purpose of smart contracts. So obviously I'm not going to explain you what smart contracts are, you already know that, but we really need to understand which problem smart contracts solve, and that's the problem of trust. So with traditional agreements, right, imagine like bank loan, that's like a traditional agreement. There's always some third party, some contract operator, which both sides of the agreements need to trust. And the problem here is that one word, trust. So that third party can have some common interest, can have some conflict of interests, and this is bad, right? So we all remember that some centralized protocols banned regular users to trade game stocks when they needed the most, right? And there was that crisis in Greece a couple of years ago when banks limited cash withdrawals to only 10 or 30 euros, right? With smart contracts and so-called digital agreements, this is not possible because the term sheets are written inside the code itself. They are deployed to some general purpose blockchain, cannot be changed, cannot be modified, cannot be corrupted, deleted, modified in any way, right? And the really nice thing with smart contracts is they rely on cryptography and blockchain as underlying technologies, so there's no need for a trust, right? But smart contracts are not perfect, right? So smart contracts are kinda limited to know about the things inside their own isolated environment, like block number, block timestamp. Maybe can call a method on some other smart contract. For example, I can, if there's some ERC20 token smart contract, I can from my smart contract query the balance of some address. But if we are on the same blockchain network, of course. But what about other data which are kind of necessary to create really powerful agreements? Right, like what's the current weather here in Amsterdam? What's the price of ETH in terms of USD? Smart contracts can't know that info, can't get that data. And that's so-called smart contract connectivity problem. And now I would like to introduce to one other term, and that's Oracle. So technically, the Oracle is any entity that can bring any type of off-chain data to the blockchain, period. This is a really complex sentence, by the way, because like what's that any entity, how they can bring that data to the chain. But to deeply understand the Oracle problem, the problem is that Oracle can be centralized point of failure inside your dApp, right? If you have only one node, Oracle source, whatever, and your whole set of smart contracts, your dApp, relies on that one entity, it's a problem. It's essentially a centralized point of failure, right? So we need some kind of decentralized environment to get us off-chain data on-chain, right? And that's why decentralized Oracle networks are so important. And the solution to this smart contract connectivity problem / Oracle problem is Chainlink protocol. So Chainlink protocol is basically open source, decentralized Oracle network of nodes, which serves as a middleware layer to provide off-chain data to various types of blockchains. So Chainlink is not a blockchain, but that decentralized network needs to reach a consensus. So to come back a bit to the Oracle problem. So what's going to happen if we have one centralized node as a service? So we are at risk to get inaccurate data or no data at all. That's why Chainlink is so heavily focused on decentralization. The Chainlink Oracle network consists of full replicas by independent and Sybil-resist node operators, which can provide off-chain data. So anyone can run their own Chainlink node, can become part of the network itself. And the thing is that all of these nodes can have their own source or sources of truth for any type of off-chain data, right? And once the request from the smart contracts goes to the Chainlink Oracle network, each of those nodes has the ability to provide their own data, but then, as I said, the Chainlink network needs to reach a consensus. It's not a blockchain, but it has its own consensus algorithm. And you have the incentive as a node operator to provide valid data, because you can get rewards in link tokens. And if you don't provide valid data, you're at risk to be punished by the network itself, because they have like the consensus algorithm. So what are hybrid smart contracts that I mentioned? Like in one sentence, hybrid smart contract is any type of smart contract which combines both on-chain data and computation and both off-chain data and computation. And they're really powerful. So how many of you know to read Solidity? A lot of people, cool. So I wrote this simple DEX. So it's like the simplest DEX ever. So you can see there's only two storage variables, like token 1 and token 2. And it have this, on the bottom, add liquidity function, so you can add some initial liquidity to the pool. And it has this swap function, so I can swap token 1 for token 2 and vice versa. There's some kind of requirements, never mind. But if you go to this uint swap amount equals get swap price, so you can see that I implemented also get swap price for this simple DEX, right? And it's really simple. So it's one line function. It basically returns the initial amount times the balance of the destination token, and divide that value to the balance of from token, balance inside the pool. Okay. And can someone tell me why it's a bad idea to use this get swap price in my DeFi project that I'm going to build on top of this DEX? You know, I want to build a DeFi protocol, but I need a price of these tokens. Why it's not a good idea to use this smart contract or this function? Yep, you can manipulate the price, but how? With the flash loan. Exactly, yeah. So what he said is basically you can manipulate this price with a flash loan inside a single block. So you can either do a series of conjunctive swaps to drain one side of the liquidity, or you can add enormous amount of liquidity to one side and you'll get inaccurate price. And the problem is, if you're building a DeFi protocol on top of this DEX, you're at risk for your users to get wrecked because of the simple inaccurate price. But imagine that now there is another DEX you're building on top of it, much better than mine, of course, with 20 lines, with audited code. It's like you know, industry standard DEX, whatever. Why still is not a good idea to rely on that TWAP Oracle as a source of truth for your prices? Does anyone has ideas, maybe? Okay. Because if you think about it, it's still a centralized point of failure. Because you're relying on only one DEX that it will provide you the correct price of any asset. But there's various sources of prices, another DEX, some CeFi protocol, some centralized exchange, whatever, like that prices can differ a bit, by that decimal places, but in DeFi, we really care about that decimal places. And that's why the good idea is to use Chainlink data feeds. So Chainlink data feeds is one of the, probably the most used product by Chainlink. It powers like over 76 billion in the DeFi world, and that number keeps growing. And basically, it has the full market coverage. So it covers all sorts of truths like DEXs, taxes, volume-based average, whatever. And it's using OCR. I'll talk a bit about OCR later if you're already familiar with price feeds. But imagine that you want to get the price of ETH in terms of USD dollars. How Chainlink price feeds work? Basically, you have on the right side of the screen smart contract calling the Chainlink price feeds to get the latest price of ETH token. And then all of these nodes have their own source of truth or truths. For example, one of these nodes can use my vulnerable DEX as source of truth for price. Some other can use some other DEX. Third node can use one DEX, one SEX, and one another DEX as source of truth. And each of these nodes has to provide their own answer to this question, like what's the current market price of Ethereum in terms of USD dollars? And then the whole network needs to reach a consensus to aggregate all of this info into one single price and then return that correct price as a callback to the calling smart contract. And if the node, one of the nodes use my vulnerable DEX as a source of truth, he's at risk to get punished outside, not punished, but to not get rewards because it provides inaccurate data. How you can see which nodes provide you data for the price feed you want to consume, for example, ETH in terms of USD. Simple, go to data.chain.link. You can see all of the info about specific price feeds, and you can go to docs.chain.link to see how easy it is to use it inside your Solidity smart contract. I'm not going to demo it because it's a simple one line of code basically, and it's really really simple, like to grab it from the official docs. And I mentioned this off-chain reporting. So if you're already familiar with the price feeds and use it in the past, you know that in the past we used so-called flux aggregator model, where each of node need to commit or to make transaction of their source of price, whatever. With off-chain reporting, now all of these nodes can communicate between themselves in a P2P network, and then they can reach consensus in that way. So imagine you're hosting, you're having let's say online store, and you have 10 products need to ship to one same address. With the previous model, you pack all of these products inside a single box, make a stamp, and then send it. With OCR, you take all of these 10 products, put it in the same box, and ship it to the end user. So let's start with another Solidity trivia. So imagine that you're making a game now. It's a simple coin flipped game. Basically, if you can have, for example, you just call a flip function with a guess as a Boolean parameter, so true, false, is it head or tails? And if you, for example, say you make 10 consecutive wins, you can get 32 ethers as a reward and become a validator, for example. And you can see how we basically calculate this block value, and how we then decide which side is true or false or head or tails. Can someone see what's the problem with this smart contract? Yep. Exactly. So this is a pseudo randomness. This is not a true randomness. And as she said, it depends on block number, and miners can manipulate that block number and can know, because like they can see these smart contracts, of course, this source code on Etherscan or whatever, like it's all public. They can know in front of time which random, so-called random value this smart contract will provide, and they can hack our game and win the grand prize. So to avoid that, we can use Chainlink VRF. So Chainlink VRF is a service which can provide you a truly random values to your smart contract, which can also, and this is really important, can be cryptographically verified anytime. So basically, malicious RNG operators are at risk. If you're creating a game which costs some money, you're at a risk to lose all of that money because someone can predict your pseudo-random values. And if you think about it, like if you call math.random function inside the JavaScript, it's not a true randomness, it's a pseudo-randomness, and it's okay for some use cases, right? If you want to host a giveaway to all of you and to give you like one t-shirt, it's okay to use math.random. But if you handle the money on the real blockchain, real people, tokens, coins, whatever, you're really at risk, and you definitely should not do that, and you should definitely use Chainlink VRF. So a couple of notable projects are already used VRF. Basically, you can select lottery winners, you can create random threads, and it's really simple to implement it inside your code. And if you are not following us, so we recently released Chainlink VRF v2. It's a new version of Chainlink VRF, much powerful, much gas efficient, and for the first time you can specify the number of random values you want from in a single call. So with VRF v1 you can only request one random value per time. With VRF v2 you can get like 5 numbers in a single transaction call and do with that 5 values whatever you want to do it, right? And it's really gas efficient in terms of VRF v1, so I definitely encourage you to try it. You can see it on our docs, so docs.chain.link. Also, we have a bunch of starter kits: Hardhat, Truffle, Brownie, Foundry, DAppTool starter kit, where you can see how you can use it inside the Solidity code and how you can properly test it, which is really important, and maybe it's not intuitive at first glance. And finally, I would like to, let's see the time, okay, we have it, to introduce you to Chainlink Keepers. So Chainlink Keepers are the way to automate your smart contract execution. So smart contracts are passive by nature. So to trigger a state change on a smart contract, you need to somehow ping it, to call some function, and then smart contract will execute some function, and then we will have the change from state A to state B, right? But if we want to do some DevOps thing inside the smart on the blockchain, there's no easy way for us to do it. So we need to use Chainlink Keepers. So basically, what Chainlink Keepers are? Imagine that you're yield farming some DeFi protocol, for example, and you need to call that harvest or tend or whatever the name of the function is in some specific time frames based on some conditions. So the solution one is for you to be in front of your laptop during whole day, try to manually click transaction on your wallet, MetaMask, Ledger, whatever, Coinbase, whatever wallet you're using. Or you can set up a simple smart contract and implement so-called keeper-compatible interface. So what is this keeper-compatible interface? You can also go to docs.chain.link to see it, but basically is a Solidity interface consists of only 2 functions. So one function is check upkeep, and the other function is perform upkeep. So check upkeep will be, in most of the case, like 99% of the cases, the view function. And check upkeep has the logic for the keepers. Basically, the keeper network from the Chainlink Oracle network will ask your smart contract on each block or in each regular time frame, like depends on the chain you are, do you need something for me? calling the check upkeep function. Like, do you need something from me? Do you need something from me? Do you need something from me? And that check upkeep function returns Boolean value, true or false, and can return also a bytes 32 value, which if you need it like as a function argument to your perform upkeep, like if differs. But basically, my check upkeep will return true or false. So if my check upkeep function return false, nothing happens. We are still in state A. If my check upkeep returns true, then the perform upkeep will be automatically called by the keeper network. And inside that perform upkeep is your logic, you know, something you need to be implemented. Inside that perform upkeep function can be a call to some yield farming protocol like call the harvest. And that perform upkeep will actually cost you money because you're updating the state, but check upkeep will be view function, free for you. To use Chainlink keepers, after you like deploy that keeper compatible interface, you just need to go to keepers.chain.link to register your upkeep and to fund it a bit with link token, and then just forget about it. So with VRF and keepers, there's some simple UIs where you create subscriptions and then fund it with some amount of link tokens, and basically you can forget about it because it's going to execute all of this stuff automatically. You also have the ability to withdraw the tokens if you need, or to fund it more, or to cancel upkeeps, or to cancel randomness, to add some new consumers, whatever, but it is that simple. So what we covered today, we covered the benefits of smart contracts. We tackled a bit of the Oracle problem. I present you a bit of the Chainlink protocol, all of new stuff we're currently building. And if you want to continue to learn more about the Chainlink protocol itself, you can go to our Discord chat to chat with the community members. Link is over here. I mentioned starter kits, so basically it's a boilerplate templates for you to write and use Chainlink inside your smart contracts. As I said, we have Hardhat starter kit, both JavaScript and TypeScript edition, Truffle starter kit, Brownie starter kit, Foundry, DevTools, Solana, all of these really useful developer tools. Obviously, number one place for you to go when you want to use Chainlink is to the official documentation. So the URL is docs.chain.link. And finally, if you're a beginner in the space or you just want to learn more about the latest trends, we recently launched Chainlink Academy. So go to chainlink.education, sign up for courses like from the beginners to more advanced. And also, if you want to participate in Chainlink Hackathon, there's still time for you to apply at hack.chain.link. I think next Friday or this Friday is the official launch, so you still have time to apply to our hackathon and win some prizes as well. I think that's it. Yeah, so we have a couple of more minutes for questions. If you have some questions, feel free to raise your hand. I see you. Yeah, we can do it.
Hi, thanks for the presentation. So I have just a pretty simple question. So on April 4th, Elon Musk tweeted that he became the largest shareholder on Twitter. On that day, the stock jumped up like 15%. Let's say I want to make sort of like a smart contract that does options based on what Elon Musk tweets, right? It's very easy to use the Chainlink system to sort of build out, to get the price of the Twitter stock onto the blockchain and, you know, use this smart contract that way. But do you see sort of, so like Chainlink is great for like numerical data input, but for example, if I want to get the data, like the actual tweet text from Elon Musk's account, is there something in sort of, would Chainlink work for something like that right now, or do you guys have something down the roadmap? Or because from what I understand, like you have multiple data providers and you sort of get like the average with the consensus algorithm. So do you like moving to sort of more non-numerical data input? Is there something that Chainlink could do, or is you guys working on something like that?
Yeah, cool. Good question, by the way. So about the first part of the question, so whatever the stock price will be dependent on tweet or whatever other off-chain circumstances, whatever. Chainlink will provide you the current price at that moment, and it's like an architectural layer, and you build on top of it, basically. You maybe want to gamble on this, never mind. But there is a way for you to make a HTTP GET request from a smart contract to any given URL on the outside world. So if you go to dogsthechain.link, find a section with any API. So any API is a service for that, and basically you can create any type of HTTP GET requests from a smart contract for a given URL. So you can even hardcode that URL inside your smart contract, or you can pass it as argument, whatever. And the second thing is that you can go to market.chain.link, where you can see all of various providers provide various types of data, because you need to pay for them to get you that data, and they have like different prices, you know, so you can you know, negotiate whatever. And also, like, we have a on our Discord channel, like on our Discord server, specific channel for that types of request events, so you can maybe host your own node to become a node operator to provide some of this data, or maybe you can ask someone to provide it, but basically go to any API, and that's the way for you to get HTTP GET requests. One thing is that you said you want a text, so your smart contracts need to know the specific type of the request, so it need to know that this is a text, or it need to know that this is a value, or it need to know that it's a number, but with several decimal steps. You need to compute that decimal steps, etc., etc. But if you know like which kind of data and in which format, like JSON or whatever, your URL will provide that data, you can use it by Chainlink in the API. Hope that answers your question.
I do have a follow-up question. So just so again, getting a text, like you say, is from the marketplace, right? But from what I understand, it's sort of like with the numerical data input, you sort of averages out, or you try to find the majority consensus from the data providers. But there's no such thing for text in that scenario. So is it just like I have to trust the data providers that I find in the marketplace, or is there sort of like if, for example, there's a malicious actor trying to feed like, oh, Elon didn't tweet that he acquired majority stake and try to mess with the smart contract that way. Does the Chainlink sort of like, is there a fraud prevention mechanism in Chainlink for dealing those texts? Yeah.
So this is still a really young project, so that's why we have like that separate Discord, you know, chat in order to like chat with all of the people. I think, yeah, I can say that currently the market.chain.link is in a rebuilding phase. So we are going to completely rebuild it to basically answer your question and your needs. So just follow our social media and you will be notified soon. That's it. Cool, thanks. Any follow-up questions maybe? 1, 2, 3.
Yeah, otherwise I have a quick question.
Okay.
As a node operator, do you have the option to only supply, let's say, certain data feeds and not everything? Or do you have to run everything in one very big monolithic node?
Yeah, so right now you need to specify which data feed you want to consume, and like the majority ones are there. You know, if you create your own token, we'll probably not supply it, but if it gets traction, you can request an addition of Chainlink price feed, new price feed, and that's constant. That network are basically constantly growing, because like for each new token, there's like a number of nodes that need to like reach consensus, so that's like a critical piece. But you can request it basically from the UI, and then we'll try to implement it for you.
Okay, thanks.
Yeah. Yeah.
Assuming I'm a local operator submitting Ethereum prices to within the network of a data provider, and I'm keep submitting 5,000 for whatever reason, so I'm being malicious. How long does it take for me to being kicked out, and what's the process is like?
Oh, good question. So I'm not the one who actually constantly working on a protocol itself, but basically it's in open source code. So if you go to smart contract kit/Chainlink, this is the official repo for Chainlink node. It's written in Go, so if you know like to read a bit Go, you can probably find your answer there. So all of this stuff, even the consensus algorithm, are open source. So at the moment, I'm not sure like what's the current time frame, but it can be easily checkable because it's not a hard-coded value, but it depends on some conditions, and it's the best way to actually deep dive into the code itself and find the answer. Cool. Thanks. Okay, very good.
I think we have time for one more question.
And if not, we of course thank you, Andrej, for your presentation today and amazing
Thank you all for having me. It was my pleasure to be with you guys. Enjoy.